What's up? It's been a while. Alright, so this is going to be like a very talk-heavy video, so if you don't like watching people talk, then I suggest not watching this video. So I wrote some notes down, and I'm going to talk about the final overview of the 2004 Kia Superturn 15 LMS that I bought all the way back in February. I wrote it down on here somewhere. February 18th. So, if you do the math, or you look at your phone, it's April 27th when I'm recording this, so it's been over 2 months since I actually got this thing in the garage. I don't know if purchase was when I bought it, or when it got moved here. I think I checked the Instagram date, so that's when it arrived on the floor. So you're looking at the 2+ weeks prior to basically seeing it and then negotiating, which there wasn't much negotiating. I think it was listed for $19K, and then I got it for $18K. Yeah, so it's been a while. The other day was the first time I got actual knife parts off of it. So if you're looking at buying used equipment, then maybe you should consider the time it takes to get said used equipment running. But that's kind of another used topic decision, or a topic to talk about. So this lathe has had 40,000 hours of idle time, 17,000 hours of cutting time. I paid $18K for it. I paid $1,600 to rig it to the house with the bar loader. I paid probably $1,500 and counting in parts to repair said things I was unhappy with on the lathe. Probably $900 plus in tooling so far, and obviously as time goes on it'll just continue to rack up because machine tooling is incredibly expensive. Let's see. I'm going to talk about some of the things that I fixed off camera. I recorded a really long video on actually fixing the chuck actuator in the back, and then I realized that was going to be not very... There was so much footage of me like fixing the chuck actuator that I didn't think I had anything worth showing. So the chuck actuator is the thing that pulls your chuck, the hydraulic chuck. It's the draw tube. It's what pulls it in and out. And mine kind of wobbles a lot at high RPM. And I've basically determined after many hours of working on it that it is the bearing inside the chuck actuator and not the spindle bearings or any other sort of device. There's a lot of... you have to dial in like concentricity between a couple adapters, and I got it as basically within book spec, well under book spec, and it still bounces. So, and I called the guys who make the chuck actuator, and they seem to think it's bearings. The nice thing is bearings are less than $500 with seals, so that'll happen at some point, or maybe I'll never get to it. It still runs, it just shakes a little. Moving on, let's see. I did a lot of sealing, lots of RTV, lots of leaks. This thing leaked like crazy. When I first bought it, they use kitty litter, which is, I don't know if you know what that... Oh, of course you know what that is. To soak up everything on the floor in the shop, and like the floor was literally kitty litter. It was like walking on gravel. It's like if you had a machine shop on a gravel road. So this thing leaked a ton, and it's not necessarily because the machine has cracks or anything in it. It's just that seals are bad. I'm talking coolant. Seals are bad, and I basically RTV'd like all the doors up here. I'll just show you guys. We'll make this a little more interactive. So I RTV'd this. Like, you wouldn't think this would leak, but it does. These seals are... The outside seals RTV'd. It leaks from this right here. It's not cracked. It's been welded, but it's just one spot for when the coolant hits it on the inside. It leaks. So that's something I gotta seal up. But yeah, I sealed even the inner seal here. So there was that seal. It would leak from down here. It's still doing a little bit of dripping, and I'm not too sure what that is. I might not be able to fix that, but I made sure the pans were installed properly. There's these extra legs that help direct coolant and chips into the actual conveyor. So that was that was a big thing. I had to install buck boost transformers. If you don't know what those are, basically the line voltage your machine sees, if you install these buck boost transformers, you can increase or decrease the incoming line voltage before the machine sees it. So here I have 240 volts coming in from the lines, which is what seems to be like a lot of the US is now. 240 is what people would call 220. It's the same thing, it's just now it's 240, as I understand. So basically this machine on a brake regen, so basically when it's trying to stop the main spindle, it's a lot of mass that it's trying to stop. So, and I don't know how to explain this, but basically it uses electricity to stop it. Like, you know what I'm talking about. It's got like a braking resistor that gets warm as it dumps electricity and it slows the spindle down. What was happening was, on that regen, it would cause the voltage, the line voltage on the lines feeding the machine to actually go up above what I'm understanding is a safety voltage circuit, like reading, and I'm thinking it was over 260 volts. So what would happen is it would go over 260 volts, and this circuit wouldn't detect that, oh, we had gone over, we're doing our regen thing, and now that it stopped regenning, like it's time to dump all that voltage. It wouldn't dump the voltage. So what was happening was you would brake regen from like 1,000 RPM, and then the phase converter started to make a different tone. And the only reason that I noticed this is because of that tone. And if you looked at the phase converter, this thing was idle, like doing nothing, but it was demanding 15 amps of power through the converter. So the converter showing there was a 15 amp load over here, and which, you know, that would cause a tone change in the converter. So doing a ton of like investigating, trying to figure out why it was doing that, and basically like it was determined that the best solution was to buck, which means you're going to lower the incoming line voltage down. And so I lowered it down to 220, and I haven't had any issues since. So that may be a solution if you have this very weird problem. I seem to have electrical problems left and right. Like I'm having another phase converter issue, but that's a whole nother topic. So buck boost transformers, that was a big thing. It no longer does that big amp draw on regen. Let's see, coolant nozzles. I've done a ton of tool block modifications, all the way from drilling, tapping, installing coolant nozzles, a lot of lock line stuff because I don't want to do hard lines yet. A ton of basically bolts are stuck, so I would have to weld nuts to the bolts and then unscrew them. I've done a ton of those. I have been in and out of this turret like a million times, changing tool blocks and modifying them. So I'll just show you guys really quick. So I just made this today, this block. The old owners, they modified their blocks. See this cut? That's not factory. So there was a ton of stuff that I've had to modify for me, basically. Cut down tool holders, boring bar holders. Here's another one I made. There's just a ton of stuff. Here's a micro 100 boring bar holder. That's pretty sweet. Yeah, I've done a ton of modifications, basically, as far as tool block holders go. But that's like a whole nother, it's not a video, but basically it's not its whole video, but it's not its own video topic, but I will talk about it in another video in the future. Okay, sweet. All right, moving on. Okay, that was coolant nozzles, I think. Let's see, the door kept hitting the turret when it would slide. The turret would come forward, it would actually pick the door up and open it as it went by, which is funny for you know, the comedic effect. But when it was shooting coolant, what it would do is it would drag the door open and then spray coolant everywhere. That's another thing. I've been sprayed by coolant from this thing probably like 12 times. I'm not sure what it is about lathes, but they're very wet. It's very yeah. One of the nozzles is a very like fine nozzle. Yesterday I accidentally forgot to turn off the coolant, or like I left the coolant on code in, and it shot the coolant all the way across the room into the wall. And yeah, so lathes, they're very wet. Let's see. Turret pins. Okay, there's a video of me actually me and my dad, taking the turret off to fix the coolant system, which turns out you don't necessarily need to do that. There were alignment pins. There was 2 alignment pins, and they're dowel taper pins, basically. And what they're supposed to do is align the turret, probably during manufacturing, to just basically get the radial alignment correct, and it's quick to manufacture. Well, I found out as I was drilling holes, I was trying to drill for the knife parts, that it would not drill center. Like, I couldn't get the theoretical Y on center, and that's because the turret was actually out of radial alignment, it's called. So I actually ended up pulling the turret back off, and I drove those pins, the alignment pins, out, and then I put the turret back together and realigned it. So that was an entire day in itself. But that fixed a very large majority of my problems, such as tools not being centered, like they would leave like a tit or whatever on stock when doing facing. So that fixed that, and then obviously the drill thing made my life significantly easier. Let's see, the live tools, the radial one's good. The axial one, which is obviously going to be the most used, is in need of bearings, but I haven't gotten there yet. Supposedly it's easy. Let's see. I think that's. Oh. So, I got 3D printing on here. I've done a lot of little 3D printing stuff. So here's like a gauge length thing. So instead of like having to get calipers out and measure it, I just stick this this here thing. There's like an inch one around here somewhere. Another thing is the parts catcher. For the small parts I'm doing is the parts catcher is too big, so when the subspindle actually comes in, it doesn't reach the parts catcher. So I made this little bin. It's 3D printed. You can't see it, obviously it's down, and then I made a much bigger bin down there, because when it swings down, usually it'll just throw the parts. So this just gives me like a wider net to catch the parts in. Definitely you'll see that in a video in the future. Obviously the machine's off, so I'm not going to actuate it or anything. On top of those 3D printed thing for the subspindle parts catcher, the parts catcher arm was broken. So the parts catcher, it moves up, but it also needs to actuate that basket kind of like in a 90 degree. So it's not, there's 2 moving bodies basically on the parts catcher, and the basket would not orientate properly. It would just slink over basically. So there was a belt in there, in the arm I had to change, and that was like an entire day, if not more than one day, because one, I didn't have the parts. Like, the belt isn't a common belt. They should have used the timing chain, but basically coolant got in there and rotted the belt out and all the bearings. But changed that, fixed all that. That was a pain. So that works. The subspindle, align the subspindle to the main spindle with there's set screws and everything, but getting to the bolts themselves of the subspindle was really difficult. Like, cheater bars basically were involved. So that was fun. The subspindle itself works. It's kind of a pain to use, because to actuate like the subspindle parts catcher, the subspindle has to be in this thing called a second home position, which is like a G30 P2, which is home 2 basically, or home reference 2. Well, there's nothing in the manual about that, so I spent an entire day figuring out how to get the parts catcher to actuate. And then, come to find out, if you want to orientate the subspindle into a position, and it does orientation to 5 degrees, so like 5, 10, 15, that kind of thing, it has to start, you can't do that in its home position. It has to be at its second home position to orientate. It makes absolutely no sense, but figured that out yesterday. But then, yeah, that's just, the subspindle on this thing is a pain to use. There's a lot of like safety circuits, but I've been slowly working through figuring it out, because there's not obviously a lot of info on these things. Along with that, on the subspindle, I've been making jaws for it, because I can't afford a hydraulic collet chuck. So for instance, this is a jaw for a subspindle. Notice there's this weird shape. Well, the idea is I'm going to be able to grab the square spacers for the knife in the sub spindle on a transfer, so it has to have this weird shape. That's yeah, I've made a bunch of different jaw sets, and it's actually working pretty good. I haven't tried the square ones yet. I put chromoly square ones in there today, so I'm hoping by tonight, hopefully, I'll have a square knife square handle spacer thing transfer complete. Let's see. Something really big on here is post processors. Now, I didn't know anything about post processors because I have the Haas, which is new, and there's a lot of post support for obviously with Fusion. There's no post for this. There's no generic post for a Kia lathe from the early 2000s. So after quite a few hours, days, weeks, and a lot of people helping me, I have sort of two posts that I work with the two and post good code and string it all together, and it's kind of a disaster, but that's kind of the way this old stuff goes. So that's kind of another thing about buying used equipment is their post support, and are you willing to edit the post? I've been learning about posts now, and so I have a pretty good grasp on how the post works and how to add edits and stuff, but there are quite a few dangerous edits that are now in there, so it's just kind of a thing that you kind of have to do if you want to post G code out. I mean, you can hand edit everything if you want, but yeah, I just wanted to work in post, so that's been a pain. Let's see, learning Fanuc, that's been also quite the learning curve, but I have a pretty good grasp on it now. It's been 2+ months, so there's nothing that I'm super unsure of now, which is good, but like learning like the ladder diagrams or how to read it, and then all the parameters, and yeah, it's been Fanuc's not easy certainly compared to like Haas, and it is an older Fanuc controller, but yeah, it was quite interesting. I mean, just learning how to upload and like edit a program or start in the middle of a program took quite a few hours to figure out. What else do we got? Let's see, the bar loader. I'm getting close to the end of the list, I swear. The bar loader will be hooked up and aligned and everything when I start producing stuff again, basically, knives. Right now, the bar loader, I don't know if it works, but it requires 15 gallons of hydraulic oil, and it's like $300. So I don't have $300 to spend on hydraulic oil for the bar loader. So what I've been doing is actually just pulling stock with the sub spindle, which is pretty cool. But that's the current status with the bar loader, and I hope it works because I can see the future of the bar loader working because yeah. So basically the only thing I've made for the knife off the lathe has been stop pins, and I guess I'll show you one. Okay, this is the first set of stop pins. Here's one, obviously, that I've gotten off the lathe. So it's going to be kind of hard to tell, but it is, it's faced perfectly and chamfered on both sides. So what I'm doing is I'm actually cutting it in the main spindle, chamfering it, doing all that, and then transferring it to the sub, and then actually facing it and chamfering it on the sub. And then basically it's dropping in the parts catcher, a done part, which is awesome because what I was having to do before, which I'm sure many of you are familiar with, is you face the part and then you part the part off. Well, there's still that pretty ugly nub from the part off blade, and I've been getting like really good results, but it's taken a really long time to dial in just this simple part. So it's definitely not easy. Making stuff on the mill is significantly easier right now for me anyways than the lathe, but it's probably down to experience. But I will say that job setup, like setting up like offsets and tool stuff, is a lot more involved on this than on the mill, and I think a lot of lathe people know that, and I can't imagine doing it on a Swiss, but that's for another year. That's basically it, and there's been a bunch of other small stuff, but I didn't want to write all that stuff down. But yeah, so that's basically it. So yeah, yeah. All right, now I'm just going to jam 2 more topics in here because I don't care about how YouTube ranks videos, and both of them could be their own videos. But basically, why didn't I buy a Swiss lathe? And then, do I suggest buying used? And third topic, would I do it again? So, why didn't I buy a Swiss lathe? Now, it's a very good question, but it comes down to price. You can't buy a sub-spindled Swiss lathe, and not saying that you physically can't. There probably is a sub-spindle Swiss lathe out there with at least C-axis for under $18,000 and or cheaper, but not that I could find, and not in the time that I needed a lathe. Now, yeah, a Swiss is a much better choice for the size of parts that I'm making, but it just didn't happen to go that way because of the cost of. There's a lot more older, normal sized lathes, CNC turning, fixed headstock machines out there because they're more common, so they're cheaper, and there's more support out there for them. So I wouldn't have wanted to buy an older, even like a 1990s Swiss lathe, because the support is getting worse and worse, and the controllers are not as good. Not saying the early 2000s was the heyday of Fanuc controllers, but I can USB RS-232 stuff very easily. There's enough data in here for me not to really worry about memory size, about complicated live tooling tool paths. So I would have gone Swiss lathe if I had knives flying out the door, and that was the solution to my problem. Really, the big topic is, do I suggest buying used? And it's a situational question. If you have a product that you're selling and you need a piece of equipment to help you sell more of the product, and it's already selling, and you already have X number of units per month leaving or something, then I don't suggest buying used if you are not a mechanically inclined type person. If you have a product that's moving out the door and you need a piece of equipment, then you should buy a new piece of equipment because it solves your problem immediately, and you should focus on selling more of the product and not focus on fixing the piece of equipment that's supposed to make you more product. Now, I bought used because I think I'm at least somewhat mechanically inclined, so things that are broken don't necessarily scare me too much. It depends on what it is. And there's a lot of good deals out there for used equipment because they have problems and people don't want to fix them, and people are scared of fixing this stuff. Now, just because you can fix something and you know how to fix something doesn't mean you can fix it quickly. As I said in the beginning, it's been over 2 months, and just the last week is the first time I got usable parts out of this thing. Now, could I put this thing in here and just start running it immediately and get the parts? Probably, mostly yes, but there's also a certain standard of machine, mechanical happiness, healthiness, that I like having, so I ended up doing all this work to get the machine in a reliable state, I guess you could say. With 17,000 cutting hours on it, what is reliable? I mean, everything works now, but you're always taking a gamble, but basically, used equipment takes a long time to fix, regardless of, whether it runs when it hits your floor or it's broken when it hits your floor. It's going to take at least a couple weeks to get it to, start banging out reliable parts. That's what I think anyways. If you're selling product, you should buy new. And if you're if you're poor like me and you're not selling product because you have a hard time focusing on selling just the product, then you should buy used. And yeah, so yeah, that's basically it. Buy used if you like torture, and buy new if you actually want to make money. And that's all for this video. So sorry for the boring video, but I just wanted to get a finished lathe overview, and now we can move on to actually making parts. Alright, thanks.